In this video, we'll be discussing properties of real numbers and more specifically to order, identify, and use properties of real numbers. So the first set of subsets that we have is a natural number. It is the numbers 1 through infinity or counting numbers, as you may have heard before. The next set are whole numbers. Now, whole numbers are numbers that are natural, plus it includes the number 0. So whole numbers is everything in the set above it, plus they have added 0. The next set would be integers. These are all of the numbers in the previous subsets. For example, 0 comes from the whole numbers, and that is the natural numbers. But it also includes negatives. Now, the next set are rational numbers. This is any number that can be written as a fraction. So you have 7/5, -3/2, 0.3. Now, I'm going to stop with that. 0.3 is technically not as a fraction. It is a decimal. However, it can be written as a fraction as of 3/10. Same thing with -1.2. -1.2 can be written as a fraction, being -1 and 2/10. So therefore, it is a rational number. Now, the number 9 is a rational number. It is a natural number. You see it here. It is also a whole number because it includes in the sets, and it's an integer, but it also can be a rational number technically because if you were to divide it by 1, you have created it as a fraction. Therefore, it can be a rational number. And last, we also have irrational numbers. Now, these are numbers that cannot be written as a fraction. So, for example, the square root of 3 is a number that continues on forever. It does not stop. Pi is the same thing. Pi is the number 3.14159. It goes on forever. E, which is dealing with natural logs, it is the same thing. It goes on forever. So those would be considered rational numbers. Now, this is a visual representation of what we've been talking about, and I want to be specific in the fact that certain numbers can be placed into multiple sets. So, for example, the number -2. It is not a natural number. It is not a whole number. It is an integer. But because it is an integer, so we would say integer, it is also a rational number because it can be made into a fraction. And the fact that we are dealing with the real number set, it is also considered a real number. So whenever we talk about classifying numbers, it can be more than one set. So for example, the number 0. Well, we know the number 0 is a whole number. Well, it is also an integer because it is inside the integer set. It is also a rational because, again, it is inside the set of the rational number because it can be a fraction, and of course it is a real number. So the only thing that it is not, well, of the natural, is that it is not irrational. Please understand that irrational and rationals do not connect in any way. They are two very different types of sets. Okay, real world connection. Where do you use this in the real world? So let's discuss an amusement park, for example. Which set of numbers best describes the values? So first, the C cost in dollars of admission for N people. So let's talk about this C first. We are dealing with the cost of admission. Well, if we're dealing with cost, that means we are dealing with money. And if we're dealing with money, we can have something that is $10 admission. We can have something that is $25.50 admission. So you actually can have a decimal when it comes to money, but because it comes to money, you're only dealing with 2 decimals, which means it can be considered a fraction. So therefore, it is a rational number. Now, we're now asking about the number of N people. Well, if you think about people, you cannot have half of a person or 3/4 of a person, or in this case, you can't have a negative person. So if you're dealing with N people in this case, you are dealing with either a whole number, because you can have 0 number of people that actually come to the amusement park, or you can have a natural number. Those are the 2 sets that N people can be determined as. Next, the park's profit or loss in dollars per week. The fact that, again, we're dealing with money, we're dealing with decimals, and in this case, we can be dealing with a negative decimal, so therefore we would still discuss it as a rational number. The fact that it's money and it's 2 decimal places can be written as a fraction. Now here we're talking about for each week of the year. Now, we could technically say that it could be a whole number because we could have 0 weeks in the fact that the amusement park has not opened yet. Or we would be dealing with a natural number of weeks dealing from 1 to 52 weeks out of the year. Now, there are two other types of properties of real numbers. One is the opposite or additive inverse of any number. A would be represented by negative a. So for example, if we have 5, the additive inverse would be negative 5. 6, the additive inverse would be negative 6. Negative 1/2, the additive inverse would be a positive 1/2, because technically, if you were to take the negative of the number, negative times a negative is what turns it into a positive number. Now, we also have something called a reciprocal or multiplicative inverse of any non-zero number. A would be represented by 1 divided by a. So for example, if I had the number 5, the multiplicative inverse would be 1 divided by 5, or 1/5. If I had 1/3, then the multiplicative inverse would be 3/1, or the number 3. Now, the reason we say a non-zero is because 0 does not have a reciprocal. If we were to take the reciprocal of 0, it would be 1 divided by 0. And we have learned back in algebra that you cannot divide by a 0, so that is why it talks about a non-zero number. And that concludes properties of real numbers.